You're sitting in your office on a hot afternoon. The air conditioner is running. The thermostat says 22 degrees Celsius, but somehow your cabin still feels warm and uncomfortable. You lower the thermostat to 20 degrees. You wait a few minutes. Nothing changes. Maybe the thermostat isn't working? You walk over to the supply air diffuser and place your hand underneath it. The airflow feels much weaker than usual, so you call an HVAC technician and begin servicing the fan coil unit. After completing the maintenance, the technician closes the unit and assures you that the problem has been fixed. A few days later, you're back in the office. The thermostat still reads 22 degrees Celsius. But once again, the room feels warm and uncomfortable. So what exactly is causing the problem? Believe it or not, the issue wasn't the fan coil unit. The real culprit was something that is often overlooked during maintenance: an incorrectly sized air filter. A filter that looks perfectly normal can silently restrict airflow, reduce cooling performance, increase energy consumption. But to understand why that happens, we first need to understand how a fan coil unit actually works and how air flows through the system. This is a skeleton 3D model of a fan coil unit based on a Walker FCU. In this model, the pink-colored section represents the return air side, while the blue-colored sections represent the supply air side. On the return air side, fresh air from outside and return air from the conditioned space are mixed together inside the plenum before entering the unit. Once the air is mixed, it passes through the filter. The filter removes dust and airborne particles from the airstream, helping to protect the internal components of the unit, maintain system efficiency, and improve indoor air quality. After passing through the filter, the air moves through the canvas connection. The canvas acts as a flexible connector between the plenum box and the FCU casing. Its primary purpose is to reduce the transfer of vibration from the fan coil unit to the plenum box and surrounding ductwork. The air then passes through the cooling coil and heating coil sections. The primary function of these coils is to exchange heat between the air and the fluid flowing inside the coils. Depending on the operating mode, the coils either remove heat from the air to provide cooling or add heat to the air to provide heating. Finally, the air reaches the centrifugal fan. The fan draws air through the filter and coil sections and then pushes the conditioned air towards the supply air outlet, where it is distributed. When selecting a filter, the first step is to ensure that the filter dimensions satisfy the opening dimensions of the FCU. The filter height must be greater than opening height, and the combined filter lengths must be greater than opening length. Another important factor we need to consider when sizing a filter is the face velocity. For a typical G4 filter, the face velocity should generally not exceed 1.8 meters per second. If the face velocity is too high, the pressure drop across the filter increases, airflow can be reduced, and the overall performance of the fan coil unit may suffer. Before we begin the sizing calculation, let's first understand how to read the manufacturer's filter datasheet. First, we have article number. This is simply the manufacturer's unique product identification number. Next, we have the type designation. For this filter, the first part, 30/30, refers to the filter series. The numbers 25 by 25 by 4 represent the nominal filter dimensions in inches. The next column is EN779, is a European standard used to classify air filters according to their filtration efficiency. The letter G stands for coarse filtration, while the number indicates the filter's performance level within that category. MERV stands for Minimum Efficiency Reporting Value. The MERV rating indicates how efficiently a filter captures airborne particles. The filter is classified as EPM1050%. Let's break that down. PM10 refers to airborne particles that are 10 micrometers or smaller in diameter. Examples include dust, pollen, mold spores, and other larger airborne contaminants. The value 50% means that under standardized test conditions, the filter removes approximately 50% of PM10 particles from the airflow. This gives engineers a better understanding of how the filter will perform in real-world operating conditions. This column provides the actual physical dimensions of the filter in millimeters. The next column is airflow pressure drop. For example, it means that when 4280 cubic meters of air pass through the filter every hour, the filter creates a pressure drop of approximately 70 pascals. As airflow increases, pressure drop also increases. A higher pressure drop means the fan must work harder to move air through the system, resulting in increased energy consumption. So, How do we calculate face velocity? Face velocity equals airflow divided by filter face area. Airflow refers to the amount of air being supplied by the fan coil unit. This is typically provided by the manufacturer and is usually expressed in cubic meters per second or liters per second. The filter face area is the total area available for air to pass through the filters. For example, if multiple filters are used, we first add together the lengths of all the filters to obtain the total filter length. If the calculated face velocity is less than 1.8 meters per second, the filter selection is acceptable. If it exceeds 1.8 meters per second, we need to increase the filter area and select a different filter arrangement. For this particular FCU, the return air opening has a length of 1,425 millimeters and a height of 352 millimeters. For this design, we will use a filter depth of 95 millimeters and select a filter size of 594 by 394 by 95 millimeters. Since a single filter is not long enough to cover the entire opening, we will use 3 filters of the same size. Let's first check the overall length. The combined filter length is 1782 millimeters. Since 1782 millimeters is greater than the required opening length of 1425 millimeters, the length requirement is satisfied. Next, let's check the height. The filter height is 394 millimeters, while the opening height is 352 millimeters. Since 394 millimeters is greater than 352 millimeters, the height requirement is also satisfied. Now that the physical dimensions are acceptable, we can check the face velocity. For this FCU, we will assume an airflow of 1,000 liters per second, or 1 cubic meters per second. To calculate face velocity, we first need the total filter face area. The overall filter length is 1,782 millimeters, which is equal to 1.782 meters. The filter height is 394 millimeters, which is equal to 0.394 meters, which gives 0.702 square meters. Substituting the values, face velocity equals 1.42 meters per second. For a G4 filter, the recommended maximum face velocity is 1.8 meters per second. Since our calculated face velocity of 1.42 meters per second is well below this limit, the selected filter arrangement is acceptable and suitable for this FCU. If you enjoy this type of content and want to see more practical engineering videos like this, don't forget to subscribe. Thanks for watching, and I'll see you in the next one.